So this is again your driven gear. Now, question for you guys, which direction? Is it going to be the same direction as gear A, or is it going to be the same direction as the driver gear? Anyone? Anyone? If I'm going to draw this, okay, I'm going to sketch this out for you, okay. Is it going to be this direction, gear B? Or is it going to be this direction? The left or the right? Anyone? Remember, this is the center of the shaft. This is where is your instantaneous. So is it the left or the right? Anyone? Today feedback is not really good. Or you are just there. Your name is just there. You're not around. Hello, can you hear me? I'm worried now. No response. Anyone?
Is it the one on the left?
You're right. You are alive. I'm glad. Okay, you're right. So this is the right one. And why you say that is because it opposes the what? The driver, yes or no? So this is wrong. Yeah, absolutely right. So it's gear B. So a lot of times students get it wrong to identify the direction. Okay, why is it gear B? Because if gear B is this way, it will it will generate a torque in this direction, yes or no? If you look at the torque generated by the applied force on the gear, it is in the opposite direction. Likewise, for gear A is also coming down in this direction, right? The driver, right, from gear B, it want to generate a torque in this direction, so you will oppose the direction. Okay, so this is critical. Okay, if you get this wrong, you get all your forces wrong. Okay, so I hope if you have to review this lecture, tell your friends you have to review this part. If not, you will not get your analysis right. Now let's go into the theory now. So this is the first thing. Okay, the direction is critical. You're going to use this in 3E05. Okay, it's going to be belt drive, gear drive, pulley drive, calculate the shaft. It's going to be the same theory. Okay, now let's look at the theory behind the analysis. Okay, so theory. So we now have a shaft now. Okay, we now have a shaft. So now we are designing a transmission shaft. So a transmission shaft, this is your neutral axis. Okay, and these are your shaft. So your shaft will be, so let me drop the transformation first. So this is your x direction. This will be your y direction. And this over here will be your z direction, right? So when it's acting on your neutral axis, right? If the moment is acting on your neutral axis, like over here, right? So when it's acting on your neutral axis, so this is your vector arrow. So when it's acting on your neutral axis, it's known as your what? As your torque. We did this before in week 6, right? You have to identify where your neutral axis is. When the rotation is, or the moment is applied on the neutral axis, is known as our torque. Okay, and then if we have some moment acting over here, right? So this is our moment in the y direction, right? And then this is our moment in our z direction. Okay, now if we were going to position two elements now, okay, so over here, we're going to position two elements, right? So this is your element H, okay, and then over here, this will be your element K, okay? One will be your element H, and one will be your element K. So if we were to look at this in a 2D world, okay, we're going to draw this in 2D. So the first orientation I'm going to draw is I'm going to draw Y. Okay, we're going to draw, this will be my Y, sorry, my X, and this is to be my Y, right? So when we draw this, and then this will be our neutral axis, right? So over here, right, at the top, this is where your element H will be, and down here, this will be your element what? Your element K. So if we if we look at this based on your moment about your Z, okay? So this is a rotation about Z. Then we look at our moment at Z, okay? So from here, what we realize is your stress X at element H and your stress X at element K all comply to the formula which is equal to stress Z over IZZ multiplied by Y. Okay. So remember your moment vectors at the head of the arrow will be compression. At the tail of the arrow will be what? Tensile. So what we realize over here, that stress X at point H will be equal to the stress, what am I writing down here? Moment about Z. Will be equal to your what? Stress max. And stress X at element K will be equal to what? 0. And this is because of element K, right? Element K is at the neutral axis. Okay. So if we were to sketch the normal stress distribution due to bending, right? So this is your normal stress X, and then this will be your Y. Okay, so this is your Y. So we know that at element H is at most what? Compression. Then it pass to the neutral axis. For this case, the neutral axis is at the centroid, right? So over here, at this normal stress state, due to bending, so compression, this is tension. So over here, this is at your element what? Over here, the stress state is at your element H. Whereas this point over here, this is your stress state of element what? K. Okay, you can see that now. Now, if we view this from a different orientation, so now this is on moment about what? Z-axis. Okay. Now, if we were to view this shaft from a different orientation now we will have over here, this will be my X, right? And then at that direction, this will be my what? This will be my Z. Okay. And this is our rotation in the Y. Okay. So I'm going to take a different view. Okay, so the same, this is our neutral axis. This is our shaft. Okay. So from here, you will have a moment about y. Okay, so moment. So now this orientation is your moment about y. So now at this point, we're going to draw our elements now. So if you look at our element at the top now, this will be your element H, and then over here, this is our element K. So what you see now is now what you get is stress X at point H, right? Or and the stress X at point K, right? The formula is still the same. Now it will be my over Iyy multiplied by z. Okay, so whatever we learned in the past few weeks, we don't forget, right? So when that's the case, so again, this is compression, right? This will be tensile. And I like to elaborate the stress H over here will be compression over here. Okay. So now the moment in Y, what we realize that stress X at point H due to the moment in Y, this will be equal to what? 0. Okay. And then stress X at K will be equal to stress max. Stress max in what? Tensile. Okay. So so basically the shear stress distribution will be the same. Sorry, the normal stress. What am I talking about? Shear stress. It will be the same. Only something changes, right? So I'm going to I'm going to bring this down a bit, okay? I'll bring this down further. Yep, here's good. Oh, just nice. Okay. So I'm going to shift this diagram so you can find the relationship. You can view it better. I'm going to put all this down here. Okay. So what you realize now, okay, I'm going to get rid of this. We are still finding stresses in the x direction. Now over here, this is now your what? Your z. Okay, no more your x. So that is your z now. So over here, now at the center, this is your element what? H. And over here, this is your element what? Your element K. Okay. So you have to be really, really careful when you calculate by looking at which moment what stress is generated. That's why when we do compound loading, what do I tell you? You have to initially, I think we did this on week 7, right? What do I tell you when we do combined loading? Is when we're analyzing the structure, we always write remark yes or no. So when we were writing analyzing this structure over here, what do we always do? We always say that element A is in compression, element B is in compression, or sometimes, right, element A is in compression, element B is tension. So this is your analysis. Okay, so it's important that we start the analysis while drawing either the free body diagram or while breaking down the forces. Okay. Right. So the next thing that we are going to consider is the torque. So we have dealt with my. Okay, we have dealt with my. We have dealt with mz. The next thing we are going to deal is with the torque. Okay. So now, again, I'm going to copy. I'm going to get this. So now we are going to focus on the torque. Okay, we're going to focus on the torque. So the torque, I will drop our transformation first. This is X, Y, and this is our Z, right? So we're going to now look at the torque and